Here are some practical ways to field test for a swap neutral and ground condition. Firstly, conduct a voltage and polarity test. Use a voltmeter to measure the voltage between the black wire, which is the hot wire, and the white wire, which is the neutral wire, at the receptacle. It should read 120 volts. Then, reverse the meter leads and measure the voltage between the black wire and the green wire, which is the ground wire. This measurement should read 0 volts. Secondly, perform an impedance test. Use a multimeter with an impedance tester function. Disconnect any equipment from the receptacle. Measure the impedance between the green wire, the ground wire, and the white wire, the neutral wire, at the receptacle. It should be very low, typically less than 1 ohm. Next, measure the impedance between the black wire, the hot wire, and the green wire, the ground wire. This should be very high, typically greater than 1 megohm. Thirdly, conduct a swap polarity and voltage test. Turn off the circuit breaker supplying the receptacle. Swap the black and white wires at the receptacle. Turn on the circuit breaker. Retest the voltage and polarity as in step 1. If the swap wires result in the correct voltage and polarity, it indicates a swap neutral and ground condition. Fourthly, perform a GFCI device test. If a GFCI, which stands for ground fault circuit interrupter, is installed in the circuit, it may trip when a swap neutral and ground condition occurs. Test the GFCI by pressing the test button. If it trips, it is likely that the neutral and ground wires are swapped. Some additional considerations include testing all receptacles on the circuit, as the swap neutral and ground condition could affect multiple outlets. If the test indicates a swap neutral and ground condition, disconnect the circuit and investigate the wiring to identify the source of the error. This could be at the panel, at a junction box, or at the receptacle itself. And always follow proper safety precautions when working with electrical circuits. In the context of the original problem where a computer power center, or PDU, had 120-volt neutrals mistakenly terminated on the isolated ground bar, leading to ground current alarm, these tests can help pinpoint the location of the wiring error. The initial attempt to use a circuit analyzer's ground impedance feature might not have immediately revealed the issue because the problem could be subtle or intermittent. Testing each receptacle on the affected circuit is crucial to finding the swap neutral and ground. Remember that even if receptacles were initially tested for correct polarity upon installation, wiring errors can occur later due to various factors. The goal is to systematically check each possible point of failure, including the panel, junction boxes, and the receptacles themselves. Using a combination of voltage, impedance, and GFCI test provides a comprehensive approach to diagnosing and resolving the swap neutral and ground condition.